in. So just very briefly, I'm going to show a single slide. Before I start, can I ask those people who have in the last month written any sort of CI script or DevOps script themselves to raise their hand? There's a function that says raise hand in your bar. It will give me an indication as to what I need to focus on. I don't see any hands, so that means that I will probably need to explain things a little bit. Okay, so let me first show you one slide as a motivation. Hang on. So we're all talking about model-driven processes in one case or another, but most of the time, and the hand show confirmed that, we are doing that in an academic context. Models have great expressiveness and they lend themselves to understanding problems because they do structuring in relationships and descendants relationships. So they give us a natural way to formulate engineering problems, but they are not. They are very focused on visualizing the structures and tie themselves to IDEs properly. Industry and my company in particular deals with large-scale projects that, if they work on models, require that the models go through a large number of process stages. So for example, we have a full stack application generator. It produces a full application out of an entity on a behavior model, produces TypeScript, C#, SQL, Docker, Helm, all of it. And after that, the application is automatically tested and run. We do our ISO certification documentation out of models. We generate our tenders for clients using models. We produce our TOGAF multi-system documentation using models and so forth. And all of that is a recent thing because we were not able to do that 1.5 years ago. So that's basically what my talk is about. It's about how we took the models out of the IDE and made it something that can run on a server. We call the thing BB8 because the systems that write our code are called bots. I want to quickly interrupt the, well, I think I'll go through with the explanation, giving the show of hands. So first I want to show why continuous integration is an important thing. So, and how it generally works. So if you are working on a source code repository and you push a change, then at the other end, there's an observer. The server retrieves the change, sees the change, and then integrated with the source code that marks the code itself, there are instructions, other bits of code that describe how this particular thing is being built. So these are then being retrieved and carried out. And depending on how you're going, you receive feedback, usually only on failure. So do we need to build on commits? Do we need on any of this? Well, if you do any collaborative work, then you want to make sure that the other doesn't get broken things. And any team greater than one has that condition. If your process has more than one step, and as an engineer, our processes all do have multiple steps, we want to control these. Everything else is repetitive work, which we want to avoid. So, and if we demand that our results have quality, we probably need to do a number of tedious checks every time. Otherwise, we're speculating. So that means under all these circumstances, we need to do CI. If we don't do CI, we're not doing it properly. So how does it work in practice? Well, first of all the projects, they start with a description of how to set up your computer. So we need some way to deal with that. Then you have to download the source code base. You have to type in the commands to make it. You have to potentially save it if you are going to repeat this process and pass that thing that you've saved on. So there may be multiple stages of install a tool, get the source code, type the command, save it, forward it. We have the great fortune that we now live in a time where setting up the computer can be canned. That is, it can be packaged up. That's what containers give us. They give us the ability to start a system in isolation, completely configured, and in reasonably safe isolation. It also gives us the ability to do this quickly and in a compatible, movable manner. So for example, the Docker container for the OpenJDK is under this URL. If I use this URL or its equivalent for Docker, then I immediately drop into a shell where OpenJDK is installed in a reproducible manner. So I can flip between completely installed environments very quickly. And if I can do it, the computer can do it too. So that's what the GitLab CI system is. And if you want GitHub Actions, that's similar. If you use Bamboo, it's similar. Even if you're still using Jenkins, that is similar. It always uses the same thing. Which tools do you need installed? Create the container, type in the commands, report on the outcomes of those commands. And those were the commands that were stored in your commit, and then pass the artifacts on if we need to. That's what that looks like in practice. So here we have a job that starts, one container, one execution. It passes the results on. This may be a completely differently installed computer doing a different part of the job. And you see that these are running in parallel, shortening the runtime. So we don't go 1, 2, 3, 4. We use the magic of Docker and containers to spread the load out. There could be 60 jobs running at the same time, making our process much shorter and reducing our wait times. We can also chain them. I'm not going to go into the details here, but you get the picture. So, oops, what was that? I'm not sure why that's thrown me out of the presentation now. Can you still hear me? No? Hello?
Yes, we can.
Yes, very good. Okay, so then I'll see if I can get that presentation back. I don't understand why it suddenly dropped. Let me see. Okay, now let's see if this works. Yeah. So what sort of inputs are we looking at? What sort of stuff do we need to work with? Well, we definitely need to use all the standard formats. We also would, as model-driven people, expect that all the model-driven tools can be taken in. We would expect that we can make connections to online resources and can pass source code. And finally, we want all the modeling technologies that already exist, at least in one scope, in the Eclipse scope. So all of this needs to run. Now we know that all of this runs inside Eclipse with the user interface on. So what we need to do is tear the user interface off. And here we come to the problem. Most of these tools are not actually primed for keyboard action. They don't recognize a process language. There is no container that incorporates them, and so there is no CI. So that was our starting position. So we reused a really old system in Eclipse called the Ant runner and an even older process configuration language called Ant. The advantage of this is that that system can call into Eclipse itself as it runs. So it's just the same as you clicking the mouse on various actions, but it's commanded by an XML-based language. I'll show you examples. I will skip this. This is the configuration model that I've taken from Eclipse to show what the conceptual structure of an Ant model for execution is. So you've got projects that have targets, that have tasks. So there's a bit of nesting here, and the targets depend on each other, so it can do an ordered execution, process execution. This is an example. It's an example. I want to focus on this a little bit. So here you see Epsilon, which is a model coordination suite, loading a model from a file, doing a for loop, printing some data out, disposing the model, and finishing. So that's an Ant build process coordinating the Epsilon toolset. This is how it works technically. You, the user, make a commit, GitLab receives it, runs the build file, which runs the unrunner, which runs the MDE task, in this case, the epsilon task, which calls into Eclipse, does the computation, and after n steps, we return and the process finishes. What can we do? What's available? These are all the built-in tasks that you can get as part of the Ant Suite free house. And these are tasks that have been contributed by some EMF subprojects. I've sorted them by topic. So this is model pattern matching, model sample generation, transformation. Some of these are terms you're probably familiar with. Some of them are just general, but they all pertain to working with models. This is a list of the built-in tasks in Eclipse so that you can install ones and experiment with ones directly. And that's how Ant interfaces with its environment. I'll skip that. To install new things on the command line into an Eclipse that doesn't have a mouse, you can use this tooling, which is the P2 director. It's exactly the same as you typing in, I want this website, I want this feature, the C++ development environment, and then it will install that, but it will not open any windows. However, you need to work with this container and the setup needs to be identical. So we're using a setup tooling called oomph that I've used here on my machine to set up my whole coordinated environment in about 20 minutes, including all the components that I need. And that is very specific. The trick about this oomph thing is that its files that describe how to set up Eclipse are itself models. So you can manipulate a base model using model-driven technology and define yourself on the fly in your install. So you can have a model-driven toolchain that configures other projects to provide the right Eclipse install on the fly without the user having to fiddle around with it. We've also backed this a little bit by writing a test harness if you need to write new tasks and creating a collection of Ant tasks, and they're both open source available. There are a bunch of limitations. I don't have time for this right now. I would be very happy to have anybody help me out, grow this vision. And I will now stop this share and see that I start a live presentation for a very short time. Excuse me. I'll see that I give you time for questions. So I just want to show you. You just give me feedback and let me know whether you can see this. Somebody? Nuno, can you see it?
Yes, we can.
Yes, you can. Good. Okay. So this is the Eclipse IDE. Here is a project that does something similar. So these are all tests from the Epsilon test suite. Some of them include other components. This one includes stuff from ATL. So you see merging of two projects is possible. So then you can run this here, the workflow there. So you see I'm running it locally in my Eclipse, which I've set up quickly. And then let's move to the project itself. Let's go to the pipelines. And now I need to log into my other computer because here I'm not an authorized user. I'm just, so this is the view that somebody from open source world gets when they are going into GitLab without having a user account. So now on the other side, I am being myself and I'm authenticated, and you will now see hopefully a process popping up. There you go. And the process starts and it starts to run all the tests and it generates PetriNet instances, converts things from human usable notation, merges with some entities, some OFO files, accesses the CSS stream of the BBC online and parses it, generates flowcharts, does for loops, rolls back transactions, and what else Epsilon and its affiliates can do. Not all of the examples that I showed you over here I have currently made active, but this project's commit is, I think, just 4 or 5 days old since I ported it from the parts that I was allowed to open source by my company. Okay, that pretty much concludes my presentation, and I hope you have lots of questions for me.